Today we're going to talk about sound as energy.
Sound is produced when an object vibrates.
The vibrating object compresses the particles together. This compression travels through matter as a wave of energy.
Unlike light, sound waves need a medium to travel through. Sound cannot exist in a vacuum.
Sound travels at different speeds through different types of mediums.
In general, sound travels faster through solids than liquids, and faster in liquids than gases.
We are going to investigate sound traveling through solids.
Done.
I was like,
Our complex question is, what factors affect sound traveling through solids?
Okay, today we are going to talk about, Today we are going to talk about sound as energy.
Woo!
Sound needs a medium like air, water, or solids. Amplitude measures how loud the sound is. High amplitude, produces a louder sound than low amplitude. Today, our testable question number 1 is, how does amplitude affect the loudness of the sound? Our claim is, the further we pluck the slinky, the louder the sound will be.
All right, now we're going to do our experiment for you.
For this experiment, you are going to have 1 metal slinky, 2 plastic cups, and 2 pieces of string attached to the cups and the slinky. What you're going to do is we're going to hold the cups to our ear to hear the sound when we pluck the slinky, and we're going to have another person pluck the slinky lightly first and listen to the sound, and then we're going to pluck it with a large pluck, and we're going to hear the sound and see what the difference is.
All right, here's
so first the small pluck. Yeah. So that was a low sound. Now the large pluck. That was a larger sound. So therefore, our evidence would be the further we plucked the slinky, the greater the amplitude was, therefore the sound was louder.
Now we are going to use 2 slinkies made of the same material. One is small and one is large. They're both attached to the blue plastic cups like we did before. We were wondering if the size of the slinky affects the sound. Our testable question is,
how does the size of the slinky affect the sound? And our claim is the larger slinky will make a louder sound than the smaller slinky.
all right, now we're going to test it for you guys. First, we're starting with the small slinky.
Tell them what you need for this experiment. Like, what did I tell them? Oh, you did?
Yeah.
Sorry.
That's okay. I can cut this part out.
Okay, sorry.
All right, now we're going to tell you what will happen when we pluck the small slinky. It makes a quiet sound. All right, now we're going to test the larger slinky. See if we can tell the difference. Oh. It makes a significantly louder sound than the smaller slinky. So now we're going to go back to our poster and show you our evidence.
Our evidence is the larger slinky made a louder sound because there is more material for the vibrations to travel through.
For our third experiment, we were wondering if the type of material the medium is affects the sound as it travels through. We have a plastic slinky and we have a metal slinky of the same size. Our testable question is,
how does the material of the slinky made of affect the sound? Our claim is the metal slinky will make a louder sound than the plastic slinky.
so first we have the plastic slinky. Someone is going to pluck it while I listen for the sound. The sound is actually pretty quiet. Next, we have the metal slinky. The sound is much louder.
Therefore, our evidence is that the metal slinky is more dense than the plastic slinky, therefore a better sound was conducted.
Through our 3 investigations, we have concluded that there are certain factors that affect sound. The amplitude of the sound affects the loudness of the sound. Amplitude is the distance that a wave oscillates from resting position. Amplitude is measured in units called decibels. The human ear has only a small range that it can hear sound. The softest sound that can be heard by a human ear is a decibel level of 0. The average human hears sound between 0 and 120 decibels. Beyond that, the energy of the sound waves are so great that it can potentially injure your ears. Another factor that affects how sound travels through solids is the size of the medium that the sound is traveling through, like if it's large or small. This affects how much sound is produced, either loud or quiet, or maybe in between. Also, the material the medium is composed of affects how sound is produced, like we saw in the slinkies. These 3 investigations and many other factors that we saw affect how sound travels through solids.
Since our complex question was which factors affect the sound traveling through solids, we found that in the first investigation, amplitude has a greater impact on the loudness of the sound. In the second investigation, we found the size of the medium affects how much sound can travel through the medium. In the third investigation, we found that the type of material the sound travels through affects the type of sound that is produced. And these are how the different factors affect sound traveling through solids.